Alrighty, so in our last video, we are picking up right where we left off. This is going to be the last Unit 5 video for 5.7. This is going to be 5.7 Part 2. And in this video, we're going to start right where we left off, and that is finishing up example 3, and then we're going to move on to example 4 and example number 5. So example 3 right here, I said the last step we had to do was we needed to check to see if our answer right here was extraneous, okay? And essentially what that means is we just need to go back in and plug in 84 for x right here. So what we're going to do is just going to go ahead and do that. Fourth root of x, which is 84, minus 3, and then plus 7 is equal to 13, okay? And then from there, we simplify what's inside the radical. It's going to be 2, and then the fourth root of 81 plus 7 is equal to 13. Fourth root of 81 is 3 times 2 plus 7, which 2 times 3 is equal to 6 plus 7, which means that our answer does check out, okay? So it is good, it is not extraneous. That is a solid answer. Now we move on to example 4. Now remember, what we have to do is we need to isolate our radicals. Now what I'd always like to do is I like to circle my radicals. And if we look, we have radicals on both sides of the equal signs, but there's nothing outside of them that is being added to, subtracted, to multiplied, divided by. So now what we do is we're going to raise both sides to the root number. Nope, not that. And again, just to reiterate, if we have a square root, because we don't have a root number outside of here, that tells us that our root number is 2. So what we're going to do to both of the sides is we're going to raise both sides to the second power. And if we do that, again, all we do is cancel out the square root signs, and we're left with what is underneath of the radicals there. So I cancel out the square root signs. I am left with 2x plus 1 is equal to x minus 5. All right, because again, I do square both sides. I just cancel out my radical symbols. I'm left with 2x plus 1 is equal to x minus 5. And then from there, we just solve for, so I'm going to kind of label these 1. Oh, keep going forward here. 1, 2, and 3 down here. Solve for variable. I'm just going to write solve for var. And we just solve for x. And we have x's on both sides. We need to move our x's to one side, and then all of our numbers, we need to actually subtract that 1, move all of our numbers to the other side. We're left with x, 2x minus x is just x. Negative 5 minus 1 is equal to negative 6, okay? And then just like we did over here, we need to take that negative 6, plug it in to see if our equations work out. Now, if we plug the negative 6 in, what we do is we get the square root of 2 times negative 6. We just plug in the negative 6 to wherever our x is at. Plus 1 is equal to negative 6 minus 5. We check it out real quick. We're going to get that, we're going to get negative 12 plus 1 which is also equal to negative 11, and then negative 6 minus 5 is equal to negative 11, which, again, if we know how to deal with negative numbers, that is basically 11i is equal to 11i. Oh. So we have, that if we plug a negative 6 in, it's equal to an imaginary number, but still, negative 6 checks out, though, because we plug it in, even though we have imaginary numbers, 11i is still equal to 11i, so it works, all right? So it is not an extraneous solution, all right? So now we go over here, all right? This is the last example, and this will be the last example of our notes for Unit 5. Now, this one's going to be a bit of a doozy because let's just start off with our first steps here. So I'm going to circle the radical, and I need to see if there are anything outside or on the outside of the radical that I need to get rid of or move to the other side. And looking at this example, there's no numbers outside here that are being multiplied. There's no numbers over here that are being added, so I'm good. So I can now raise both sides to the root power, which is just 2. So I'm going to raise both sides to the second power. Powers cancel out over here. I'm left with 8x minus 15 right here is equal to, and now if I look, I have x squared here, and that's just going to turn into x squared. So now I'm in a little bit of a different situation. Now I have 8x minus 15 is equal to x squared. Now this is not just a linear, equation that I can just solve for x. This is a quadratic that I have to do a little bit more work for. So I'm going to first of all, I'm going to just go ahead and move everything to the side there. So I'm going to get 8x x squared minus 8x plus 15 is equal to 0. And then from there, what we're going to do is we need to solve this. Now, it's been a bit of time since we've, factored, but we're going to go back to factoring a little bit, because if we look, we have ourselves a quadratic trinomial in which a equals 1. And remember how we factor our trinomials out. All we really need to do is, when a does not equal 1, all we need to do is we put in the 15 at the top and the negative 8 on the bottom, and we need to find two numbers that multiply to positive 15, add to negative 8. Those numbers happen to just be negative 3 and negative 5. And then from there, we can go and say that x minus 3 times x minus 5 is equal to 0. Because again, all we're doing is basically rewriting this equation as this right here. Now, what we're going to do is we're going to use something that's called the we call it the zero product property, all right? And essentially, the reason why we do that is it basically says that if these right here, if this times this is equal to 0, then how to solve for x is we need to set this one equal to 0, and we need to set this equal to 0, and then solve for x. So that's what we're going to do. We're going to set x minus 3 equal to 0, and then we're going to set x minus 5 equal to 0, okay? Because if if one of these is equal to 0, then the whole factor itself is going to be equal to 0, and that's what we're looking for, the numbers that potentially make this whole equation equal to 0. So from there, we're going to go ahead and solve. So we're going to add 3 on both sides, add the 5 on both sides. And instead of getting one answer, we're going to get 2. We're going to get x equals 3 and x equals 5. And just as we did with our last examples there, we need to check not only just this answer, but both our answers to see if any of them are extraneous. So let's go ahead and do that. So I'm going to plug in the 3 real quick. I'm going to do 8 times 3 minus 15. Underneath the square root sign is equal to, plug in the x out there, to my original equation, which is just 3. And let's see, if I do this, I'm going to get the square root of 24 minus 15 is equal to 3. 24 minus 15 is equal to 9, which is indeed 3. So 3 is a good number for right now. And then if we check out our number 5, let's see, we're going to get 8 times 5 is equal minus 15. I multiply the 8 times the 5, I get 40 to minus 15. Square root both those. 40 minus 15 is equal to 25 in the square root, which is indeed equal to 5. So both of these answers are good solutions for my radical equation there. Okay. So that is where we're going to end the video right there. This has been the Unit 5, video notes videos. And again, if you need any question, I might put out maybe a few videos this week that go over like a few homework problems. If you have any questions, just please make sure you guys are letting me know. Thank you for watching.